Good morning. In this video we are going to see how the AG2 simulator works. This video is especially important because we are going to execute a simulation, and we are going to teach you and show you how to understand the results that the simulator shows during and after the simulation. First of all, we have to open the simulator, and now we wait. Okay, once the simulator has been opened, we can close the welcome window, and you have to open the simulation that you have designed. In this case is this. Open. Once the simulator has loaded the scene, you can go here to simulation properties, and you can set the value of the duration of the simulation. In this case is 10,000 seconds of simulation. And now if you want, you can try to execute the simulation, but the simulator has a checker, a configuration checker, to say you if you have missed or failed any special logic configuration. In this case, the simulator says to you that the client 2, client 3, and client 4 do not have or aren't enrolled with a broker, with a service node. You can use here in the right side the navigation list of clients, and go to the client 2. You select the properties of the device. You can select the client 2 here and push the button. The simulator are going to show you and highlight the simulator charging in the right side the features of the specific device. Now you can see that the broker that this client is not enrolled with a broker, and you have to choose to select the broker. You can do also the same with the client 3, and finally with the client 4. Okay, once you have you have configured the scene, and you have completed the logic configuration, you can execute the simulation. I strongly recommend you that before start the simulation, push the view of OCS circuits here to see how the circuit changes. Now we are in the simulation. You can see in the top of the simulator some new tabs. For example, this tab is the tab of resources. You can see the performance, the percentage of use of the cluster, and you can see how and now in this tab, in total result, you can see a resume of all the entities in the simulation. Clients with requests and jobs. Now you can see the resources, the clusters, for example, the optic, the switches, and at the end the brokers. And you can see all the traffic, all the information is registered here in this tab. It's especially important here the OCP tab, because you can see here each instance of OCP that was created during the simulation. You can see here the resume, and if you push the see details button, you can see the wavelet that was used by the OCP, the time of the time when the OCP was required to be established, and for example the time here that was used. It's very important here the messages, how many messages went across that OCP, and all the traffic in megabits that crosses this OCP. Now you can see that in each pair of switches just one OCP was created. It's very interesting to see here, because to see this because in the next simulation we are going to see how between the PCE1 and switch 4 the simulator is going to create a new OCP. We change to the design view, and we are going to change just one parameter. You can see, first of all, you have to check the speed of each link. You can see each link has just 100 megabits per second in both directions, and you can see here in the cluster that this cluster has 3 cores, and each core works at 100 megahertz. Now we want to check the traffic that the clients are creating. Here you can see that each 100 seconds the client are creating a message with the size of 1000 megabits, and each message requires 10 megaflops to be processed here. Now we are going to change one value of one client, and we are going to see how the simulator change the performance to use in a better way the resources of the network and the grid. Now we are going to change this value. We're going to change 1000 per 5000, and we are going to require more processing power, for example 100 times more. Now we select the OCP view, and we can execute our simulator. Now you have seen how the simulator has created a new OCP, a new direct OCP between PCE1 and router 4. Here you can see in the total results tab the percentage of the simulation, the remaining percentage of simulation. Now we can have a review about in the OCP results. We have to find the PCE1 and switch 4, and we can see that between those pair of hopes, the simulator has created 4 OCPs, and you can see the time of the request, the time of establishment, how much time does the OCS circuit last, and the number of messages the number of messages and the amount of traffic that crossed the OCP. This proof is very interesting, but if you want to see how the simulator change its behavior again, we can change again the values, and you can see how the simulator returns to the behavior of the first simulation. And now we can see that the simulator hasn't created a new OCP. We can go to the tab to the total results. We can see the percentage of simulation. Okay, the simulation has ended, and we can see that the simulator hasn't created a new OCP between PCE 1 and router 4 because their network with the default OCPs. That concept of default OCP is created and was developed by Tricia Halley in her paper. Now you can check the tab of OCP results, and you can see that just one OCP between hops was created, and you can see, okay, again all the traffic again. Okay guys, I think this is all for this video. Have a nice day.